Hi everyone, welcome to this GCSE Foundation Revision video. We're working down the 100 days to go to the GCSE Maths exam and we've got 81 days to go. So this is the 81 days to go video, and today we're going to be focused on tree diagrams. And I really like this topic. It's one of my favourite topics in terms of probability and being able to find out the probability of things happening. So for instance, if you've got the revision card, so revision cards, card number 73 on the foundation set, we've got the probability that the train arrives late is 0.4. And then we're looking at the train on Saturday and Sunday and looking at the probability that the train will be late twice or on time twice and so on, or late exactly once and so on. So I really like this topic. So I'm going to go through the topic, go through a couple of questions, give you some to try yourself, and then hopefully you'll find it useful. So let's get started. Okay, so today's topic is tree diagrams, and I really like this topic. And what I'm going to do is I'm going to do a tree diagram question for you. So I'm going to go through it, and I'm going to go through different questions based on it. Then I'm going to get you to do one yourself. Then we'll look at one involving fractions as well instead of decimals. Okay, so here we've got a tree diagram. We're told that John and Dan take turns throwing a ball at a target. So John's going to throw a ball at a target, and then Dan's going to take a ball at a target. And then we've got this tree diagram, and we're told the probability that John hits the target is 0.8. The probability that Dan hits the target is 0.3. So John's better at hitting the target than Dan is, because Dan's probably hitting it's only 0.3. And we've been asked to complete the tree diagram. And what's fantastic about these tree diagrams is they show us all the possible outcomes, because obviously John can hit it and Dan can hit it, so that's a hit. We've got John could hit it and Dan could miss it, so that's a hit-miss. We've got John could miss it and Dan could hit it, that's a miss-hit. And finally, John could miss it and Dan could miss it, and that would be a miss-miss. And we've been asked to complete the tree diagram. So that means we've got to write the probabilities on the branches. So here, the probability of John hitting it is 0.8. That means the probability that John misses the target would be 0.2, because these probabilities have to add together to be 1. He either hits it or he misses it. So that means they're going to add together to be 1. Now, in terms of Dan, the probability that Dan hits it is 0.3. So the probability that Dan misses it would be 0.7. And then here again with Dan, the chance of him hitting it would be 0.3, and the chance that Dan misses it would be 0.7. And we're asked to complete the tree diagram, and we've done it. We've labelled all the probabilities on the branches. Okay, so let's have a look at our first question. So we've got our tree diagram with the probabilities labelled on it. Now we've been asked to find the probability that both men hit the target. So that would be a hit and a hit. And if we want to find the probability of John hitting and Dan hitting, what we do is we multiply the probabilities on the branches. So we will do 0.8 multiplied by 0.3. And 0.8 multiplied by 0.3 would be 0.24. So that means the probability that both men hit the target would be 0.24. Fantastic. So that would be 0.24. So if we want to find the probability of John hitting and Dan hitting, we just multiply the probabilities along the branches. So we just do 0.8 multiplied by 0.3. If we want to find the probability of John hitting and Dan missing, we would do 0.8 times 0.7. Actually, let's fill out the rest of these. So the probability of John hitting and Dan missing would be 0.8 multiplied by 0.7, and that would be 0.56. The probability of John missing and Dan hitting would be 0.2 times 0.3. So 0.2 times 0.3 would be 0.06. And finally, the probability of John missing and Dan missing would be 0.2 multiplied by 0.7, which would be 0.14. And I find that quite useful whenever you've got a tree diagram to write down all the probabilities of those outcomes by multiplying the numbers along the branches. And I'm actually going to write down what each of the outcomes are. So we could have a hit and a hit, a hit and a miss and a hit, and a miss and a miss, just so we've got the outcomes and the probabilities of each of those outcomes. So the first question says, what's the probability that both men hit the target? The answer would be a hit and a hit, that'd be 0.24, and that's it. Okay, now let's have a look at our next one. Okay, the next question says, find the probability that neither man hits the target. So neither man hitting the target would be a miss and a miss. So that'd be a miss and a miss. So that'd be 0.2 times 0.7, which is 0.14. So the probability of neither man hitting the target would be 0.14, and that's it. Okay, next we've been asked to write down the probability that exactly one man hits the target. So exactly one man hitting the target would be either John hitting and Dan missing, so it'd either be that outcome, or John missing and Dan hitting, so that outcome. So we want either one of those two outcomes, either a hit and a miss or a miss and a hit. So when we want either a hit and a miss or a miss and a hit, we add together those two probabilities. So we're going to add together 0.56 and 0.06. So we're going to do 0.56 plus 0.06, and that's equal to 0.62. So the probability for exactly one man hitting the target would be 0.62. And just to recap that, because it's either a hit and a miss or a miss and a hit, we just add those two probabilities together, and then that will give us our answer of 0.62. Okay, let's have a look at the last part of this question. So we've been asked to write down the probability that at least one man hits the target. So at least one man hitting. Well, at least one man hitting, well, that would be both of them hitting. That would work. A hit and a miss, well, that would work. One of the men's hitting the target. A miss and a hit, yep, one of the men's hitting the target. And a miss and a miss, no, that's not going to work. That's not, because it's at least one man hitting the target. And if they both miss, it's not going to be that option. So that means that we can either have a hit and a hit, 0.24, a hit and a miss, that's 0.56, or a miss and a hit, which is 0.06. So if we add together those probabilities, that's going to be the probability of at least one man hitting the target. So we're just going to do 0.24 plus 0.56 plus 0.06, and that's equal to 0.86, and that's it. Okay, let's have a look at a tree diagram question. Now this is one for you to try, and the question says the probability for rain on Monday is 0.7 and the probability for rain on Tuesday is 0.4, and we've been asked to complete the tree diagram, and then we've been asked some probability questions based on the tree diagram. So feel free to pause the video now and to complete the tree diagram and then to try these probability questions. Okay, so our first part is to complete the tree diagram. So the probability of rain on Monday is 0.7. So that means the probability of no rain would be 0.3. Then we've got Tuesday. The probability of rain on Tuesday is 0.4. So the probability of no rain on Tuesday would be 0.6. The probability of rain on Tuesday would be 0.4. And the probability of no rain on Tuesday would be 0.6. So fantastic, we've completed the tree diagram. Okay, now we've got some probability questions based on that. The first question says, find the probability that it does not rain on either day. So that's the probability of no rain and no rain. And then the next question says, find the probability that it rains on exactly one day. Now what I'm going to do here is, before I actually answer these probability questions, what I'm actually going to do is list the outcomes. So we've got rain and rain, rain and rain. We've got rain and no rain, rain and then no rain. We've got no rain and then rain, no rain and then rain. And we've got no rain and no rain, no rain and no rain. And then let's find the probabilities. So the probability of rain and rain would be 0.7 times 0.4. That's going to be 0.28. The probability of rain and no rain would be 0.7 multiplied by 0.6. That's equal to 0.42. The probability of no rain and rain would be 0.3 multiplied by 0.4. That's going to be equal to 0.12. And finally, the probability of no rain and no rain would be 0.3 times 0.6. So 0.3 multiplied by 0.6 is equal to 0.18. So I've listed all the outcomes: rain and rain, rain and no rain, no rain and rain, and no rain and no rain. And we've got the probabilities of each of those. So the first question says, find the probability that it does not rain on either day. So that would be no rain and no rain. So that would be 0.18. So 0.18. And that's it. So the probability that it does not rain on either day would be 0.18. Okay, next we've been asked to find the probability that it rains on exactly one day. So that means it's either going to be rain and no rain, this option here, rain and no rain, that rains on exactly one day, or no rain and rain, because that rains on one day as well. It wouldn't be rain and rain because that rains on 2 days, and it wouldn't be no rain and no rain because that doesn't rain at all. So that means it's either rain and no rain, which is 0.42, or no rain and rain, which is 0.12. So we just add these two probabilities together, 0.42 plus 0.12, that's equal to 0.54. So that means the probability if it rained on exactly one day would be 0.54, and that's it. Okay, let's have a look at our last question. Now this time we were dealing with fractions rather than decimals, because obviously probabilities can be given as fractions instead of decimals, and likewise tree diagram questions can involve fractions rather than decimals. And just remember that if you're multiplying fractions, you multiply just the numerators and the denominators together, and that'll give you the answer when you multiply the fractions. Just multiply the numerators and denominators. So here we've got Nova plays 2 games. The probability she wins the first game is 1/3. The probability that she loses the second game is 7/8. And we've been asked to complete the tree diagram, and we've been asked to find the probability that Nova wins both games and find the probability that Nova wins at least one game. So we've got this tree diagram question involving fractions. Feel free to pause the video now to try it yourself if you want to. Alternatively, I'm going to go through it in a moment. So the first part says to complete the tree diagram. So we've got the first game here, and then we've got the second game here. So the probability that Nova wins the first game is 1/3. So that means the probability of her winning it would be 1/3. So that means the probability that Nova loses the game would be 2/3. And I'm assuming here that it's either a win or a lose, because in the question it's saying win or lose. Obviously, if I was writing this in one of the practice questions, I'd probably give a bit more detail in terms of it. So here that Nova plays the first game, and the probability of her winning it is 1/3. So the probability of her losing it would then be 2/3. And then with the second game, the probability that she loses the second game, losing, is 7/8. And so that means the probability of her winning it would be 1/8, because obviously the win and the lose have to add together to be 1. And if losing it is 7/8, then winning it would have to be 1/8. Okay, and then here the second game again, the chance of her winning it would be 1/8, and the chance of her losing it would be 7/8. So we've completed the tree diagram. Now the question says find the probability that Nova wins both games. So that's a win and a win. So we want to find this probability here, a win and a win. And then the next part says find the probability that Nova wins at least one game. What I'm actually going to do is I'm going to list all the possible outcomes, and I'm going to find the probability of each of them, and then I'll use those probabilities to help us answer these two questions. So we've got a win and a win. So that would be 1/3 multiplied by 1/8. So we do 1 1 times 1 is equal to 1, and 3 times 8 is equal to 24. So the probability of her winning both games would be 1 over 24, 1/24th. And actually here, the probability of her winning both games would be 1 over 24. So that's the first part. Now, win and a lose, we've got a win, which is 1/3, multiplied by a lose, which is 7/8. Again, we just multiply the numerators and denominators. 1 times 7 is 7, and 3 times 8 is 24. So the probability of her winning and then losing would be 7/24. Losing and then winning, so losing and then winning, that'll be 2/3 multiplied by 1/8. And if we do 2/3 multiplied by 1/8, 2 times 1 is equal to 2, and 3 times 8 is equal to 24. Now you notice that this fraction cancels down. I tend not to want to cancel down in these questions until the very end if I have to, because whenever I have to add options together, it's actually handy if they've got the same denominator. So if I cancelled this down, I get 1/12, and then I would have to add that maybe to something else later. So actually, whenever I'm multiplying and getting these probabilities here as fractions on the branches, I tend to keep them as the same denominator if it works out that way. And finally, a lose and a lose. This outcome here, a lose and a lose. Her probability of her losing the first one is 2/3. The probability of her losing the second one is 7/8. And if we multiply those together, 2 times 7 is 14, and 3 times 8 is 24. And let's just check that. 1/24 plus 7/24 would be 8/24, plus 2/24 would be 10/24, plus 14/24 would be 24/24. So that's fantastic. They all add together to be 1. So the first question says, find the probability that Nova wins both games. That's a win and a win. So that's 1 over 24, 1/24. Fantastic. Okay, next we're asked to find the probability that Nova wins at least one game. So at least one. So that's not losing both, so it's not an option. Losing both, that's not going to work. A lose and a win, that would work. That's at least one game. A win and a loss, that's at least one game. And a win and a win, that's at least one game. So she could either lose and then win and then lose, or win and then win. They would all mean that we should win at least one game. So we need to add together 1/24, 7/24, and 2/24. So if we do 1/24 plus 7/24 plus 2/24, we'll get our answer. So 1/24 plus 7/24 would be 8/24, plus 2/24 would be 10/24, and that's it. And that means that the probability of Nova winning at least one game would be 10/24. Now the question doesn't say to cancel that down. If it does say to cancel it down, you could just half both of those to be 5/12, and that's it. So the probability that Nova wins at least one game would be 5/12. And that's it. And that's it. So we've gone through tree diagrams, and I really hope you find it useful. Tree diagrams is a topic again where we don't know exactly what context or style the question may be in. You know, it might be trains being late, it might be traffic lights, it might be someone taking penalties. We're not entirely sure, we can't predict what the examiner is going to write. So what I'd highly recommend you do is to try the practice questions in the description below, because then that might give you an example of lots of different situations where tree diagrams can be used. Whether you're filling in some numbers and then, you know, working it out yourself, whether you're finding the probability of perhaps of 2 trains being late, or exactly once, or at least once, and so on. So those practice questions will be really useful for you. So really hope you find today's revision video useful. Remember, 3 o'clock tomorrow, the next one's going to be on YouTube, so tune in then, and hopefully you find that one useful as well. So see you tomorrow. Cheers. Bye.